So let us take a question from a projectile over here today, where a bomb was released from an aeroplane. Okay, let us say if this is an aeroplane, right? If this is an aeroplane, maybe this one, okay, and from this aeroplane, a bomb is released, okay, from this aeroplane a bomb is released, that means if the word is coming like released, then definitely the initial velocity of the bomb is nothing but zero, we can say it, right? So the bomb is released from this point and it is going downward like this, right? And it strikes somewhere on the ground at a point A. Okay, let us say this bomb is striking the ground at a point A, right? Now the question is that, my dear friend, bomb was released from an aeroplane when it was at a height of 1960 meter above a point A. And it's also given that the location or the height or altitude of the aeroplane from the point A above the ground is this one, right? And this is given to you as 1960 meter. 1960 meter is your height, not height of the aeroplane, right? Now from this point A on the ground, and it was moving horizontally with a speed of 100 meter per second. So the speed of the aeroplane horizontally like this, right? It's given to you as 100 meter per second. So this is the speed of the aeroplane when it's moving horizontally, right? Now the question is that, my dear friend, find the distance from A of the point where the bomb strikes the ground. So because at the point of dropping the bomb, aeroplane is here, but definitely bomb will not strike here. It will strike at a point, maybe let us say B. So we need to find B. What is the distance of A to B? So let me write the question. At what distance from A will bomb strike? At what distance from A? Because the bomb is released at A. When the aeroplane is just above A, bomb is released at this point. But it will not strike directly over here, okay? It will strike at certain point over here, okay? So this will be just like this. You can see the projectile motion, okay? If you remember, this will just follow this trajectory, okay? And this will strike at this point. Hello, Ramoria. Hello, good morning. So you can say at what distance from A will the bomb strikes the ground, strikes the ground. This is the question, my dear friend. It's given that the horizontal velocity of the aeroplane is 100 meter per second. Good morning very much, my dear friends. Good morning. So we need to find the distance of AB. So my dear friend, we need to understand, let us consider the motion of the bomb in the horizontal and vertical direction separately. Okay, if the bomb is released from this point, so we can just draw, let me draw a figure like this. Okay, so the bomb will attain the velocity of the aeroplane, okay? So if you consider the initial velocity and break the components, you can see this is the horizontal component of the bomb, which is just as usual speed of the or velocity of the aeroplane, which is 100 meter per second, right? And if you consider the vertical velocity, initial velocity of the aeroplane into the y direction, the vertical one, it will be equal to how much? It is just dropped. The question is that bomb was released from aeroplane, released. Just you are dropping without not forcing it. So the initial velocity in the vertical direction will be zero, isn't it? because you are just dropping it like this, okay, just dropping it. So it will be like this. Now, if you remember the vertical motion, the downward direction, if you consider a negative, then we can say that the in let me write for the vertical, for the vertical direction, what are the things which are happening. If you apply the if you apply the formula s equal to ut plus half at a square, right? A is basically g over here, right? Acceleration due to gravity. You can see the initial velocity. If you consider the total displacement which is happening into the vertical direction is this one, isn't it? And that is equal to 1960 meter. That is the height of the aeroplane, altitude of the aeroplane. So can we write in place of s as 1960, right? So being a downward direction, we can just put a sign of minus over here, because if you consider this as a reference, all direction towards this is, below this is negative, right? So from here we can say the displacement which is happening after dropping the bomb, the displacement of bomb is minus 1960 meter, is equal to the initial velocity of the, in the vertical direction. I'm just asking, I'm just calculating in the vertical direction, what is the initial velocity? It is 0. So this component will be 0, isn't it? 0 into t, it will becomes finally going to be 0, right? Plus half gt square. Hi, hello, very good morning, Ramoria, very good morning. Half gt square. What is the value of g over here? G is 9.8 meter per second, but into this direction it will be negative. So it will be minus 9.8. The sign convention you can take as per your convenience, right? Into t square, into t square. Let me shift a little. Let me shift a little. I think it's visible now, right? Right. So from here you can see minus and minus will be cancelled, and this 2 will, you can just write 160 into 2, or maybe divided by 9.8 is equal to t square, isn't it? This will give you the t square actually. So from here, just replace decimal and you can see 20 could be there, right? And from 98, this will divide 196 into 2 times. So just divide in 2 times, so it will become 20. So 20 into 20 is the value of t square, and we just take the square root into both the sides. You get the time period of the flight when the bomb strikes the ground is equal to 20 second is the value for the time period you calculate it, my dear friend. T equal to 20 seconds. This is your answer for the time period. No, this is not your final answer. Our question is that at what distance from A will the bomb strike the ground? Because the aeroplane released the bomb at this point, okay? But it will not strike directly, okay? Because aeroplane is not standing over here. It is having some velocity. So the initial velocity, horizontal direction, in the horizontal direction, this is ux, is 100 meter per second, 100 meter per second. So this will also impart some, this will be the responsible, this will be the responsible component which will help, which will not allow the bomb to strike directly at A, okay? It will just force to strike at a point somewhere at a point B, okay, at a point B. How? Because the aeroplane is having certain velocity, and that velocity is basically the velocity of the bomb also, right? Now, what we did, we just break the component of the bomb, right? The horizontal component and the vertical component. Horizontal component of the bomb is having 100 meter per second, which is the velocity of the aeroplane, right? Now the vertical component is 0. We applied for the vertical direction x equal to ut plus half gta square. All direction below this is negative, so s will become minus 1960 because s is equal to this altitude. This is the displacement which is totally happening, right? So minus 1960 will be there instead of plus. So this minus equal to ut. So for the vertical direction u is 0, right? So this will become 0, 0 into t, right? Minus minus plus half gta square, but g will be minus 9.8 because g is also acting downward, right? From here, this is g, this is g. Now my dear friend, when you just solve it, you get here the value of t. The value of t is 20 seconds, right? Now if you got the value of t, what is the problem in calculating this distance, my dear friend? What is the problem? This is the requirement, the distance of AB. Okay. Simply for the horizontal motion, what are the things happening for the horizontal motion? Simply, s equal to ut plus half at square. If you apply it, the same formula s equal to ut plus half at square as you applied over here, right? When you apply the same, then you will get the displacement, that is the a to b. This is your s. Now s will be equal to the length of AB, because this is the distance from point A where the bomb strikes. So this is equal to AB, and which is equal to ut plus half at square, this formula. But for the vertical direction, initial velocity is 100. So for the horizontal direction, initial velocity is 100. For the vertical direction, it was 0. So that's why we will put in place of this u, as 100 into t. The value of t is 20 plus half gta square, but the acceleration into the horizontal component will be 0. So that's why the component of half gta square over here is nothing but it's equal to 0, right? So this will give you 200 into 20, which is equal to 2000. So when you just strike the aeroplane, from the aeroplane the bomb, it will strike not at A, it will strike at 2 kilometer after A. So because 2 kilometer, that means 2000 meter, or 2 kilometer is the distance of AB. So in this way we solved our question, my dear friends. The question was that at what distance from A will the bomb strikes the ground? So the bomb strikes the ground at 2 kilometer from the point where the bomb is released. So if you consider this as a vertical direction, this is 90 degree. So from A to B, this distance is coming as 2 kilometer, my dear friend, right? 2 kilometer. So in this way you can solve such questions of projectile, my dear friends. You can solve very easily. So if I will say which formula which I have used over here, then I will say yes, the formula of s equal to ut plus half gta square is the only formula which I have used over here, right? If you want, I can show you. Okay, let me reflect it again. Okay, so the question is for, if you consider the vertical direction, what is the formula which you have used? The s equal to ut plus half at square, right? This is the formula, and here u is basically nothing but u into the horizontal direction, ux, which is 100, into t. We have calculated t as 20, just multiplied 20 over here, and acceleration into the horizontal direction is 0. So this will be equal to half into 0 into t square, right? Because acceleration into the horizontal direction is 0. This we need to understand in the projectile question. No acceleration is acting into this direction. Okay, all the acceleration is acting only downward. So the g will be acting over here, but no acceleration is acting into the right direction. Okay, so that's why for this, for the horizontal, when we are considering the horizontal motion and applying the formula is equal to ut plus half at square, we will simply write s equal to, with, because this 100 is nothing but your ux, right, ux plus half at square, but ax into the right direction, horizontal direction is 0. This is giving you ax equal to 0, as here ux is 100, right? But you consider the acceleration due to gravity into the downward direction, the vertical component of acceleration is nothing but your g, right? And if you consider the horizontal component of acceleration, maybe gx, this is equal to 0 for this motion which we are discussing, right? This is for the acceleration, this is for the acceleration. The components we need to understand. We did two times the things. One, we consider the once we consider the vertical direction and applied s equal to ut plus half at square, and second time we used the horizontal direction and we just used the time what is the value which we have evaluated from the vertical direction equation, that t is used in and substituted, this t is substituted over here, right, into this formula is equal to ut plus half at square. Here you can see this t, this is the t, this is basically t, right? And initial component of the horizontal is your ux, horizontal motion is ux, and ux is 100, so 100 into 20 plus half at square, but acceleration into the horizontal direction is 0, right? So that's why you get the value of s as equal to 200 meter. So this will give you the value of 2 200 meter, 20 into 100, that is 2, not 200, 200 into 10, which is 2000. So 2000, you can see 2000 meter is your answer. Or we can also say this as, this distance as equal to a to b as equal to 2000 meter, or we can also say in 1000 meter 1 kilometer is there, so we can also say it as maybe 2 kilometer. So the bomb will not strike at this point A, bomb will strike at this point B only, right? And bomb will just strike over here like this, it will follow the trajectory like this. Okay, it will not directly hit the ground because the aeroplane is also moving here. So when the aeroplane is moving, this motion is also imparted to the bomb also. So the bomb also attains this velocity. If you consider the bomb, so the vertical direction, the initial velocity of the bomb is 100 meter per second, which we can assume because that is the speed or velocity of the aeroplane. And if you consider the initial vertical velocity uy, that will be 0, right? So in this way we can solve such question, my dear friends. Thank you so much for watching. I think if you consider the bomb component, initial component, right, like this, the horizontal component as 100 and vertical as 0, right? And similarly for acceleration, the two components gx and gy, in this way horizontal is 0, vertical is a small g. You can just apply this and solve two times. Once you apply the vertical motion, in the vertical motion s equal to ut plus half gt square, use the component of, for the vertical one use the component of uy and gy, right? And for the horizontal one, when you consider the horizontal one, use the component of ux and gx, right? Here you know the value of gx or the acceleration into the x direction, it is 0. You can see this is 0, right? So this need to be considered over here, and this will give you a 2 kilometer or 2000 meter of distance. The bomb will not strike directly at a, it will strike at a position b, right? So this is the distance or the horizontal range we can say when the bomb strikes the ground, right? And this is your answer, my dear friend. The 2000, this 2000, right? So the bomb will not directly hit when the energy drop from aeroplane at A. It will hit at a point B. Okay. The two things which you need to remember: the component of velocity when you are dropping just at the beginning of the motion. This is and break those components into horizontal and vertical components, right? The initial one, because when you're dropping, then the component of the velocity will be u, not v. Then there are two components, horizontal component and vertical component, that we broke it over here. This is the bomb. Bomb will have attained the velocity of the aeroplane into the horizontal direction, because the aeroplane is going horizontally, not vertically. It is not going to crash, right? So it is only giving you the horizontal component to the bomb, the initial horizontal component to the bomb, and no vertical component to the bomb, because it is just released. Released, that means ui is 0. For the gravitation also, acceleration due to gravity, two components will be there: acceleration due to gravity into the horizontal direction in where the aeroplane is going, which is the velocity of the bomb also. This will be 0. And when we consider the vertical direction, this one, because the bomb is dropped from here, for the vertical direction, the acceleration due to gravity will be the acting acceleration due to gravity, that is from ground, that is a small g. So these two components is considered for the consideration of vertical and horizontal calculations, right? For the vertical direction, s equal to ut plus half gt square is applied. From this we get the value of t. And for the horizontal also we applied the s equal to ut plus half gt square, and this t is substituted over here. We just consider these two components of the horizontal velocity and horizontal acceleration here. These two are considered over here, and we calculated 2000 meter or 2 kilometer is the distance of AB. So the bomb will not strike here, the bomb will strike at a point B, and it will just explode over here. It will just explode, bomb blast over here, okay, B. Thank you so much for watching, my dear friends. Thank you. Take care. Bye bye. See you into the next class. Take care. Happy learning. Bye bye. See you, my dear friends.